Welcome to Math with John, Simplifying Square Roots, Lesson 2. Factoring numbers and pulling out perfect squares are the two basic techniques for simplifying square roots. The process ends when what is left underneath the square root can no longer be simplified. Note that equation 5 from the previous video is posted here since it is the crucial reason why perfect squares can be pulled out of square roots. The expanded version is useful for making more complicated problems easier and faster to solve. The general rule for pulling perfect squares out of square roots is detailed on the last two lines of the page. I will provide quite a few examples of this formula in this lesson. Simplifying root 360 is a good problem for demonstrating all of these ideas and how they work together. To simplify root 360, factor into primes, pull perfect squares out of the square root, repeat until what is left cannot be simplified. Equation 15 starts off by factoring out the obvious factor of 10. For equation 16, 36 equals 6 squared and 10 is equal to 2 times 5. 6 factors into 2 times 3, so that gets us to equation 17. Be careful about the parenthesis to make equation 17 precisely accurate. By an exponent rule, 2 times 3 all squared is equal to 2 squared times 3 squared. That gets us to equation 18. Finally, equation 5, the extended version, is used to pull the perfect squares out of the square root. Equation 19 is a product of three square roots, and two of them are perfect squares. Root of x squared is equal to x, applied to both 2 and 3, gets us to equation 20. If you are a bit uneasy about equations 17 through 20, write down equation 17 on a piece of paper and simplify it to get to equation 20 repeatedly until it's just boring. And then later that day or the next day, repeat the process until you can just write out the steps first time, every time. Equation 21 is just combining 2 times 3 into 6 and 2 times 5 into 10. And then the problem is finished because root 10 cannot be simplified. Finally, the shortcut method is to remember that root 36 is equal to 6 and pull 36 out of the square root immediately. Since root 10 cannot be simplified, this completes the problem. Numbers that cannot be simplified and steps used to simplify them. Prime numbers and products of numbers to the 1 power cannot be simplified. Or rather, the square roots of these numbers cannot be simplified. I will use the phrase cannot be simplified to apply to numbers such as root 10, and we'll use shortcut language and just say that 10 cannot be simplified, really meaning that root 10 cannot be simplified. The first 7 primes are 2, 3, 5, 7, 11, 13, 17, and 19. Memorize this list of primes. It will make factoring and simplifying square roots easier and other types of problems as well. Prime numbers cannot be simplified. So root 2 and root 7 cannot be simplified. Also, root 47, for example, cannot be simplified since 47 is a prime number. The numbers 6, 10, 14, 15, 21, and 30 are products of primes to the 1 power and thus cannot be simplified. So if you get any of these numbers inside of a square root by themselves, then that square root cannot be simplified. Root 42 is equal to root 2 times 3 times 7, and products of prime numbers to the 1 power cannot be simplified. Examples of numbers that can be simplified and steps used to simplify them. Equations 25 and 26 showcases two ways of factoring the number 40. In equation 25, factor 40 into 5 times 8 and then into 5 times 2 times 4. Pull 4 out of the square root to get root 40 is equal to 2 root 10. In equation 26, factor 40 into 4 times 10, and then pull 4 out of the square root to get 40 is equal to 2 root 10. Either way works. In equation 27, start off by pulling out a 4 from the square root of 48, getting us to 2 root 12, and then pull out another 4 since 4 divides into 12. 2 times root 4 times 3 is equal to 2 times 2 root 3. And finally, multiply together the pulled out numbers to get a final answer of root 48 is equal to 4 root 3. In equation 28, if you remember that 16 divides evenly into 48, then this can be done with the shortcut method of pulling 16 out of the square root with a two-step solution of root 48 is equal to 4 root 3. In equation 29, remembering that 25, which is 5 squared, divides evenly into 75, allows a two-step solution of root 75 is equal to 5 root 3. In equation 30, 16 divides evenly into 96. But if you don't see that when doing this problem, then pulling out 4 twice works just fine. Just be careful to properly multiply the numbers that are pulled out. In this case, 2 times 2 is equal to 4, so that root 96 is equal to 4 root 6. In equation 31, dividing 2 into 98 gets you 49, and you have to memorize that root 49 is equal to 7. This means that root 98 is equal to 7 root 2. And finally, if you have a larger number such as 112, factoring out 2, since the number is even, leads to 112 is equal to 2 times 56, which equals to 2 times 8 times 7, since 56 equals 8 times 7, and 2 times 8 can be multiplied together to get the perfect square 16. Pull 16 out to get root 112 is equal to 4 times root 7. Thank you for listening. Please like and subscribe. Have a good day.